Who felt it last night? You should talk to them. Okay, so coming back. For number 14, they just said by the limit process. How many formulas could we have plugged into? 3 of them. So when I show you the answer key, is this necessarily exactly what you did? No, but what needed to have happened by the end of your process? 7. You should have gotten 7. Does that make sense? Okay, so grade the 7 and don't start frantically writing down what they did. If they use a different formula, you're not necessarily going to find your mistake. Number 38, we'll come back to. That's the weird graphing stuff, right? Number 40, we'll come back to too. That's the weird graphing stuff. Number 46 was super short. Oh yeah, you were going backwards, right?
Yeah.
Is it that one?
Yeah.
Number 46, can someone just tell me the formula really quickly so we can see it? What did they give us? The limit?
Limit as x approaches 0, negative 2 plus h cubed, plus 8 over h.
They asked you to pick out who the function is and who C is. What formula would you guys, now this is actually out of all the problems in homework, besides the graph, this is probably one of the most AP-ish problems. Not because of them telling you find the F and find the C, but having you look at something that has been plugged in and figuring out who is F and who is C. What formula does this look like? Wait, it's not X, it's H approaching 0, right?
Oh, yeah.
What limit formula does this look like? The definition with the delta X or the H? The F of A plus H minus F of A all over H, or the F of X minus F of A all over X minus A? How do we do that?
I think it's the x plus.
Second one. Not the X plus H though. Why not the X plus H? What's plugged in? Isn't there an A? Does anybody see an X in any of this? Okay, so it's not the F of X one at all, so it couldn't be the first or the third, right guys? Doesn't the first have F of X plus H minus F of X? That doesn't work. And the third one has F of X minus F of A. That doesn't work. It had to fit this one. Can anybody talk through how they figured out X cubed and negative 2? Frank, what did you do?
Well, you can assume that if that's the original formula, that F of A, if it's A, then it has to be negative 2, because negative 2 cubed is 8, positive 8, or I mean negative 8, but it's minus when you subtract.
So she saw that negative 2 cubed was a negative 8, which minus a negative would be a positive.
Right, so you can assume that your F of X is X cubed because it's like F of X, yeah, that's what you're doing with the formula, so you know that it's cubed. So.
Good. And there's probably an easier way to see. I bet, Maggie, I bet you thought of the negative 2 being cubed because you saw that negative 2. What do you think?
Yeah, that's it,
Yeah. So, no, well, you checked it though. So you see right here an A, and an A is negative 2, and the negative 2 plus H kind of blocks that all out. So you ask, okay, well, it was plugged into who? Well, somebody cubed. There's your X cubed. And then check it. Well, then negative 2 plugged into the function should be this guy. Negative 2 cubed is negative 8 plus 8. Yeah, that works. Does that kind of make sense, guys? All right. Well, we'll come back to that when we need it. You were just trying to go backwards. 46, it was a short one, but I thought it was kind of a confusing one. If you didn't realize you were working backwards from an already plugged in formula. All right, we have, I think, another even, right? There's a couple. 66. Did you have to use that formula? Did they force your hand on that? Did they write down? Come on, you guys should have all written down directions. Why is Porcosat always answering? 66, did they tell you to use this formula?
Yeah.
Okay, so we got forced. If they told us to use the limit as x approaches a of f of x minus f of a all over x minus a, then we were forced. We plug in f of x, we plug in f of a. How did they make this jump? From this step to that step, what did they do?
They simplified the complex fraction.
So, Issa, what would you need to multiply top and bottom by to simplify this complex fraction? No, not him. Yeah, 4 and x. You guys agree with him? When you distribute, the x's cancel and you just get 12. When you distribute, the 4's cancel and you just get 3x. When you get really good at that, you don't even really need to write it. So this step is practical as long as you know how to simplify fractions really, really well. Yeah? Do you guys see why I put that in the summer packet? And on the summer review quiz? It's kind of important. Negative 3/16. And then number 76. A function cannot be differentiable where, or I should say, yeah, a function will not be differentiable anywhere where it's not continuous. And where is this function not continuous? Oh, yeah, that's right. So, not differentiable, the derivative does not exist at the discontinuity. Is there a question that I ignored?
I was gonna ask if it's okay if I wrote like parentheses negative and like
Yeah, like differentiable.
differentiable from like a certain interval.
Yeah. So there are different ways of writing. You could say that it's differentiable for all x not equal to 3. You could have written? Oh my goodness. You could have written what they wrote, which is differentiable everywhere but or except at x equals 3. Or you could have done multi-interval notation from negative infinity to positive 3. Open 3 to infinity. If you want to be super snazzy, you could use a union symbol, but you don't. Yeah, all those say the same thing. If you guys didn't have a graph, because this was totally like, hey, cheat and use your graphing calculator, forget that. How should you have known that this was a vertical asymptote?
Bottom.
Yeah, the bottom, and it's non-removable because it does not factor out. And if you plug in a 3, isn't it number over 0? Oh my goodness, there's like 4 different ways to check. Just kidding. More like 2. This one is a piecewise function, true? I think, wasn't it piecewise?
Yes, it was.
Random. Do the slopes agree as you come in towards 1? Do the slopes agree as you come in towards 1? No? You sure? What are the slopes seeming to go towards at 1 on this piece? What's the slope seeming to become? Flat, right? And flat, I think I heard it, is a slope of 0. So the slopes seem to be going to 0 from below, true? What do the slopes seem to be doing from above? So are the slopes coinciding? Maybe you guys will understand this a little bit more when we cover the shortcut rules. Long story short, the slopes seem to be coinciding. The slopes seem to be coming to 0 from either side, which is a dilemma. Because as we get a little better at derivatives, we might accidentally be like, not from the graph, but from the piecewise function, be like, yay, the slopes agree, so the slope is 0. But the problem is, no, it's not. Because what was the problem? Not whether or not the slopes coincided, but the problem was f is not continuous. And how do we know that from a piecewise function? We plug in below and we plug in above. And what's going on with the 2 different points? They don't match up, they don't agree. All right, kiddos, that's the end of section 2.1. I'm going to go back to the very, very top so that you guys can ask questions. I'm guessing already 37 to 40 I need to talk about. So just save that for me. If you have any other questions besides 37 to 40 that you need to see worked out or even explained? Yeah,
It was an odd problem.
that's okay. That's actually better because that means that you still got 3C. Okay. What else? 61. 29. What else? 33. What else? Alright, volunteers, who can do what besides 37 to 40? Expos are up the front, just take a spot on the board. Maggie, what do you want? Any of them? Okay, who wants to narrow it down for her? Yvette, what do you want? You want 3C? It's all yours. Cosette, what do you want? 29, it's all yours. Alright, Maggie is 61, 33. Oh, come on, James, thanks. Markers on the front table. Grab a spot. You can also grab a spot at the sideboard. There's enough for one person over here. I'm going to mark down participation. It made me smile. What'd she say? I thought I
She
did it.
said she did it wrong. I said, what if they did it wrong?
You know what? Be confidently you. You go, friend Coco, you go. It's a calculus movie.
It is.
It is.
It is.
Limit does not
For a brief
exist.
moment, it is.
Perfect moment. Yeah, when she kind of just thought about how cute a boy was. But whatever.
And the guy's head disappeared, and she just knew.
Yes. Okay, so that got one. James got one. Hey, it's all different people than last time. Good job, guys. Yvette, oh no, Yvette's up to 2. Alright guys, 2 participation points. This is the thing to beat right now. Alright, as they're working, let me get the graphs ready to talk about. Some of the things we're talking about today, as we get better at section 2.2 and 2.3, they will become easier, especially the graphs on the board.
Sorry if I don't have enough space.
You can move out the other board if you want to set and then erase them. Move out just a little bit. Is that enough?
Mm-hmm.
If you want to move this.
Thank you.
Yeah. 9661. Sorry, I missed something.
Oh, yeah.
Yvette, what was the question on yours? Was it average? Secant length? What did it say?
Didn't identify it's going to be
Oh, so we're supposed to go here and find the information about it. What were those points on the graph you had? There were 2 of them, right?
1, 2,
Uh-huh.
and 4, 5.
If that helps for letter C, you were supposed to go to the graph and find the f of 1 and the f of 4 values from the graph. Those are the same thing as the y values. So you did 5 minus 2 over 4 minus 1, and then you just plugged in.
Does this make sense?
And the f of 1 is 2.
That's like, it's like, goes down here. Ooh, I like it all except don't forget limit. Oh, it's there too.
Okay, so then you plugged in, and conjugate, and then simplified. And then you're good. Yeah, I think that works. Good job, kiddo. And the limit disappeared because you plugged in. Yeah. Number 29 was a conjugate problem. If you didn't like the delta x, you definitely could have used the h. 33 also is h. Plugging and chugging. Some of you guys don't like fractions, huh? And I'm guessing if some of you made mistakes on 33, I don't know, this is just a guess. It might have been in plugging in, but probably most of you, if you made a mistake, it was probably right here. And some of you just need to take the time on that. It is what it is. Some of you need to take the time and do it carefully. And actually think about x plus h times x plus h. Stop killing those poor little puppies. And so James got what he got by foiling and then distributing. So negative 4th x squared. There we go. 2 times negative 1/4 is negative 1/2 hx or xh either way, and then negative 1/4 h squared. But it doesn't end up mattering.
Why am I not talking about it? Mattering is a word. I don't know why I thought it wasn't for a second.
It doesn't end up mattering because the h ended up just going to be 0 anyway. But I would think that clicks the correction. H factors out, reduces, plug it in, keep writing limit until you're done. Alright. Questions about anything you see on the boards? Clarification? If you guys ever need to take pictures, I'd rather you, to be honest, take pictures of what's on the boards and then work it out yourself later than frantically write it down, unless you find a mistake and you can correct it easily and then keep going from there. I don't like that.
I just have a question for Tracy.
Yeah.
I know that you were supposed to plug in and do all of that, but how did we get from 1 times x minus 1 plus 2 to x plus 1?
Just distribute. So if you distribute the 1, then you would have 1x minus 1 plus 2, and then just combine like terms.
Okay.
So
But what about the 2? Why isn't that in there? The other 2 connected to the x minus 1.
oh, he was. But negative 1 plus 2 is just plus 1.
Okay.
Does that make sense? Anything else? Clarification? Explanation? We can call on them and have them explain. Eva.
For 33 on after you cancel the h's, what happened is? I'm confused.
Okay, this right here, after you cancel the h's, then it's time to plug it in. And when you plug it in, you get this equation right here, who is f prime of x. And I think according to the problem, it said something to do with parallel to, right?
Yeah,
Is it
parallel to the line.
So first of all, you wanted to actually get the line in something that you understood, because I think it was x plus y equals 0. And you have to subtract the x. So first of all, you have to get it to be y equals mx plus b, and then you can say parallel to means same slope. And what is the slope right now? Negative 1. So then you take the derivative, which stands for a function of all possible slopes, 2f, set it equal to the negative 1, and then you're solving. So when you solve, then you find, let's see, multiply both sides by a negative 2, x is equal to 2. And now it's our job to go ahead and make an equation of the tangent line with this slope at this point. So we go ahead and plug into y minus y1, which I'm going to find by plugging into, equals f prime of 2, which I already know is negative 1 because of up here, times x minus 2. So I have my negative 1, plugging in 2 squared is 4, divided by 4 is negative 1, so minus negative 1. Then I have negative x plus 2 minus 1. So yeah, we have to take the derivative, which stands for all the slopes, set it equal to the one I needed to figure out when that happens, and then go ahead and make a line based on that fact. Good job. Good question. And a clarification and explanation. Okay, is it graph time? Here we go. Question. What was the original function on number 33? Can I just use it as an example? This problem. The original function is what? Okay, what does that graph look like? Parabola and it's facing down. Okay, what does the derivative end up equaling? And what does that end up looking like? A line. Can we just take that before I even talk about this? Real quick. Can we just take those two and just look at the graph? So we know, because of the work that James did, f of x is equal to negative 1/4 x squared. And we know f prime of x is equal to negative 1/2 which, once we do section 2.2, we'll be able to make this jump so much faster than the jumps that you see about on the boards with all the different derivatives that they did. That's why we have to get into 2.2. But, can we just talk about the graphs really quickly? I'm going to color code this really quick. So let's make the original be black. Let's make the derivative be red. This is what number 37 through 4 is having you do. Realize that an original function and a derivative function both have graphs. So how can we take one of them and figure out the other one without actually knowing equations and solving? This guy, downwards parabola centered at 0, 0, true? And then he's going to be fairly, whatever, I'll see him in CalcAB. We won't go into how when x is 1, it's negative 1/4, and when x is, etc. It's going to be pretty spread out, pretty wide. But we have a parabola. Okay. Now I can graph this guy, negative 1/2 x. He's going to be centered at 0, 0 also, right? He's going to have a negative slope, fairly negative, something like this approximately. What if we didn't know the derivative? Could we have figured out just from the downwards parabola that the derivative function is going to look like that one line?
Yes.
The answer is yes, but how? Why is the derivative at 0, 0? I'm going to use blue to show baby tangents. Big tangents is skimming, right? What's the slope of the one at 0? M equals 0. So what did the derivative need to be at 0? 0. Let's say we went down just a little bit. Let's say at this tangent line, m is equal to negative 1. Is that plausible? Possible. Because it is a negative, and maybe it's a negative rise over run of over 1 down 1. Okay, fine. M equals negative 1. So at this point of tangency, where does the tangent line equation need to be? At negative 1. But what happens as my tangent lines keep going and keep skimming? They get more and more and more and more and more negative. Where is this line going? More and more and more and more and more negative. What happens as I come this side of 0? Let's say this one, m equals positive 1. It's possible. It's positive, maybe up 1 over 1. So at this point of tangency, where does the derivative need to be? Up 1. Positive needs to be up 1. What happens as my tangent lines, as I keep moving, what's happening to those slopes? Steeper, 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 steeper. They're increasing in a positive direction, so it needs to increase in a positive direction. Another hint is once we learn the power rule, which you guys have already kind of learned, whenever we bring down a power, what happens to the power in the derivative? It always decreases by 1. So if you have a parabola, its derivative must be a line. All right.
Just my question, why is the derivative line slanted down? Couldn't it just be like a horizontal?
It couldn't be horizontal because if it was horizontal, you're saying all the slopes are exactly the same y value. Because remember, this is y equals f prime. Now, if you're just talking about the one tangent line at this one point, that would be horizontal. If you're talking about the tangent line here, it's a negative number, so it had to go negative, more negative 1. So remember, this one equation represents all the different slopes, not just one. So it has to represent this positive slope at, let's say, negative 5. That needs to negative 5 be a positive number. And it needs to represent this really negative slope at, let's say, positive 5. It needs to have this negative number.
Why did you say that the parabola on the one side is increasing in it and decreasing?
The parabola, as I move, which I'm actually not supposed to do, but as I move right to left, the parabola is decreasing in its y values, but the slopes are getting steeper and steeper and steeper, so the slopes are increasing. Because remember, this is like a 0 slope, this is like a 1, maybe a 5, maybe a 10, maybe a 20, maybe a 50, maybe a 100. The slopes need to be going up. So the parabola, yes, its y values, well, technically you're supposed to read this way. So the parabola is increasing, but its slopes are decreasing to 0. And and then it keeps on decreasing to bigger and bigger negative numbers. Okay, so let's go ahead and use that. I'm just going to show you really quickly the sketches of these without tons of explanation, because once again, as you get better at section 2.2, I will also be able to explain better these graphs I'm showing you. But in all of these, what have you been given? The original, and you're trying to graph the derivative. So I need to think about, I need the y's of the derivative to represent the numbers of the slopes to f. So I'm going to go to every single one really quickly and say, ask myself the question, is there a place where the derivative should be 0? What am I saying? Is there a place when the slope of the tangent line would be 0? Okay, is there a place on 37 where the slope of the tangent line would be 0? Where? 4. So I'm going to say the derivative needs to have a 0, an x-intercept at 4. Where else is there a derivative in any of these graphs that would equal 0? A slope of a tangent line that would be 0. The maximum in number 40 would also be a flat horizontal tangent line. I'm going to put a 0 at that x value because the derivative needs to equal 0 at that x. Now, why am I not going to put any more zeros for 39 or 38? Sharp points. At sharp points, the derivative does not, cannot, will not exist. So I can't put any points for either of those. All right, well now what do I know? Wait, we just talked about the derivative of a parabola will always be a line because you bring down the squared and you make it a first power. It'll always be a line. Huh. What's going on to the slopes in this one? If it's really negative, less negative, 0, and then really positive. Am I going to have an increasing line or a decreasing line? Because I need negative numbers getting smaller to 0 and then going positive. I'm going to roughly have a positive line. And if you're like, oh, you just drew a tangent line. Okay, fine, I don't care. Make it cross through or something. The sketch would be some sort of positive line that crosses through the point 4, 0, which will represent at 1 being a really negative slope. Actually, to be honest, it probably should be a lot steeper than that. That is a really steep slope. If I was to do like 2, for instance, if I was to sketch that, I could probably do a rise over run of 1 or 2. Oh, maybe it's not that steep after all. Oh, either way. I need to have negatives. I need to go through 0. I need to go positive because that's what my slopes are doing. Negatives going to 0 and then going positive. Negatives going to 0, going positive. Number 38. Wait, that's a straight line, and all straight lines have what kind of slope? A constant slope. So question, if this portion of the graph has a constant slope, can I approximate by doing a little baby rise over run if I wanted?
Oh,
I don't know. It's been freaking out. Now you guys are getting period 1 struggles. Okay. Does that look kind of like a negative 1-ish? Over 1, down 1?
Yeah.
Okay. So let's say that this slope over here is negative 1. If this slope is negative, okay, the slope on the left is a negative 1. What do you guys think the slope on the right is going to be? Yeah, it's up, right? We could probably pretend like a little rise over run, a positive one. So I'm going to say this. Oh, it got worse. This slope is a negative 1. This slope is a positive 1. So what am I going to say about the derivative? It's going to be negative 1, negative 1, negative 1, all the way to 0. And then it's going to be positive 1, positive 1, positive 1, sorry, all the way to the 0 of the original function, which is the same thing as 4. All the slopes are negative 1. All the slopes are positive 1. The derivative has to be negative 1 constantly up to 0. The derivative has to be positive 1 constantly up to, I apologize, I keep saying 0, up to 4. And at 4, the derivative does not exist. Both of those are empty. Number 39 is a little bit different. Once again, the derivative is not existing, but here's the struggle. It's not quite getting to a 0, but is it getting closer and closer and closer as I go to the left and as I go to the right? Isn't it getting closer to a horizontal? You guys see it? It's getting closer to a horizontal tangent line. Getting closer. Both of them actually end up having a horizontal asymptote at 0. Both sides, to the left and to the right. But this one, all the slopes are negative going to 0. Negative numbers going to 0, so it'll look like that. And as you come in towards that cusp, as you come into that sharp point, the slopes get steeper and steeper. It's actually going to have a vertical asymptote there. So it's going to have a horizontal asymptote, negative numbers getting closer to 0, and it's going to have a vertical asymptote. The derivative is at 0, because it's going to get steeper and steeper and steeper. Just trying to make that in my page. That looks better. There we go. And on this side, on the other side, positive numbers coming in towards 0 as you go out. And getting steeper and steeper as you come in. It's going to actually be one of these. It's going to be kind of the 1 over x function with the vertical asymptote at 0. Right.
Are you graphing what the derivative would be?
Exactly.
Okay.
So I'm looking at the slopes and then seeing how the slopes are getting closer and closer to 0. So I have this getting closer and closer to y equals 0. And the slopes are getting more negative, more negative, more negative. So I have it getting more negative or decreasing. Then I have the slopes going closer to 0, closer to 0. As I come in, the slopes are increasing, so I have it increasing. Last but not least, this one's probably one of the funniest ones. Is this a parabola?
No.
So is the derivative going to be a line?
No.
Okay. But I do have a 0 here. And I do have the slopes going which way? Negative or positive? As they move to the right, they're going negative and going more negative. So it's the slopes are decreasing, but not in a linear way. The slopes are decreasing, but not in a linear way. And what's going on as I come this direction? Positive or negative? Uphill, right? Positive and getting more positive, so increasing. Probably going to be something like that. Now the curvature, probably a lot of you guys would get really confused, even if you've been understanding 37, 38, 39. We'll talk more about that as we get to know derivatives a little bit better. Remember, you guys have just scratched the surface of a derivative. You've learned the definition of a derivative, which is the limit definition, which is important, but you haven't gotten familiar with them yet until we keep going in section 2.2. Long story short, you haven't gotten fast with derivatives because you've been solving them a long way. Does that kind of make sense? So if you're not fast with them, how are you supposed to do or analyze quickly what a derivative would look like? Maybe right now isn't the best time, but it is an introduction. All right.
So for number 40, with the graph of the actual function, is that like to the fourth power?
It's just a semicircle. So it would be the positive square root of x squared plus y squared. The positive square root of 4 minus x squared. Sorry. We've gotten y by itself. Does that make sense? Kiddos, we need to get into 2-2. Because we did not get to play with these yesterday. We're going to need to play with them tomorrow, but I need you to at least be somewhat familiar with them. So these are the, 1, 2, 3, 4, 5, 6, 7, 8 rules? Kind of 7, 8 rules we talked about yesterday. You guys hopefully wrote them down, but what did we not get to play with? I just did quick answers. That's no fun. Can you guys tell me why the answers are what they are? No? Let's start with the first one. What rules are we going to use to solve the first one? Power rule, but wait, there's something first. Constant multiple rule. Is there a coefficient in front? And the answer is yes. Since there's a coefficient in front, constant multiple rule says he gets to stay, no big dealio. Then take the derivative of x to the 12th. Now you're right. Power rule tells us to do what with that 12? Bring it down. That's what I say, bring it down. And then I do what to the power? Decrease it by 1. Now does it make sense why it's negative 36, x to the 11th? question. If we were solving this the long way, how would we have to do it? If this was section 2.1, I gave you this as a problem. Exactly. How fun would that have been? What would you have had to do? Ooh, you guys were scared of the cube on the 12. You have to go down and hopefully by this point you would be definitely doing Pascal's, right? And not just giving up, my slackers. You have to go down to the 12th row. Well, technically 13th if you count the first one. Get all the coefficients. You would cancel out just one little guy. Pull out all the H's. Yeah, okay. Do we like the power rule? Yeah, let's keep doing the shortcuts. Sound good? Okay. How about example number 2? Why is the answer what it is? What rules would we have to use? Sum and difference. I'm allowed to take each piece, the derivative of each term, whenever there's adding or subtracting. But what else did I remember? The constant multiple. I could leave the 1/2. What's something else I could have done before leaving the 1/2? Couldn't I just have distributed it? No calculus. Couldn't I have just rewritten and said, well, that's confusing. Can't I just make it 1/2 x to the 4th plus 7/2? Could I have rewritten it and then taken the derivative? Yes. How am I going to take the derivative of this guy? Keep the 1/2. And then the power rule. Power rule says bring down the 4. Decrease the power by 1. Sum and difference says do it one at a time. So that's the first derivative. Now it's time for the derivative of 7/2. What's the derivative of any constant? 0. And if you need to, you can think of it as x to the 0 when the 0 comes down. Depends on what rule is easier. But either way, that's just going to be a 0. The final answer is 2x cubed. And I think that's who's hiding down there, right? So what happens in power rule every time? Because of the constant multiple, this number ends up multiplying by the other number, and then you just decrease by 1. Now, do you guys see how I rewrote this one before I took a derivative? You need to get really good at that. So let's, before we even do any more examples, let's talk about that whole rewriting thing. This is pretty much where we're going to have to end today. Finally, though, tomorrow we can just plan to continue. Let me show you guys. Yeah, we'll grab it. Okay, but for you to be ready for our competitions tomorrow, you got to practice tonight. And there are going to be some tricky ones. Let me show you a few versions of tricky. What if you were supposed to derive 3 square root of x? Or what if you're supposed to derive 4 over x squared? Or what if you're supposed to derive y equals the cubed root of x squared? Or what if you're supposed to derive 4x plus 1 all over x? Are those quite as basic as the ones we were just doing? No. Not so much. But what do you notice in this little table, just trying to kind of help you think through how to take a derivative of some of these nastier ones? What's the first step actually say? Derive or rewrite? No calculus in this step. No calculus. The calculus happens right here in the differentiate. So how could we rewrite this guy to put him or make him able for us to use a rule to derive? Yeah, it's 3x to the 1/2 power. Hey, as soon as that's a power, can I now take a derivative? Yeah, it's just going to be maybe a little messy when I go to take that derivative. How about the next one, 4 over x squared? How would I rewrite number 2? Sorry, letter B. That's division. There's no division in any of my basic rules. That's for a very important reason. How could I rewrite 4 over x squared? 4 times 1 over x squared, and how can I rewrite that as a power? -2. Ooh, I can use that power rule. This one, I could rewrite it to be x to the 2/3. Ooh, that's a power rule. This one, can you guys do this one? Pause. You have to split up. And then simplify. I can take the derivative of that, or that, or that, or that, but I couldn't from the get-go. I need to rewrite, then use my rules. Kiddos, play around with CalcAB rules tonight. I hope and pray you are caught up on 2.1. Good contact on 2 when it's necessary, because you have to be done with that before you can move on. I'll see you guys later. Test corrections tomorrow. I'm going to be gone from the room at 3:30 in the volleyball game. You can come ask me there or come tomorrow. They're due by the end of the day tomorrow. I'll be here after school then. Just let us say, not here today. Don't say anything. I can't act like it was me. That makes me sound really That totally works. How are we doing test corrections?